So cool, let's begin the session. Say hi to smart contracts. Uh, I think most of us might know this, that it all started with the 9-page long white paper that an anonymous character, Satoshi Nakamoto, dropped. For the first time in the history of mankind, he made us realize how imperative and effective it is for us to interact in a trustless fashion without any central authority control governing us, right? So in a nutshell, what a blockchain does, it's an open distributed ledger that record transactions, but not just in a verifiable manner, but also in a permanent fashion, which basically means everything that goes into blockchain is immutable. So you can't change it. Even the developers who wrote the code can't change it, which actually makes it more secure and reliable, right? So far, Web3 has come a long way. We have seen enormous use cases of blockchain. The total value logged in DeFi right now is more than 60 billion. We have seen use cases in healthcare, gaming, crowdfunding, and all those sort of things. But a quick question that might pop up when you look at all these use cases is that, is blockchain technology alone capable of this wide range of use cases? So the answer is probably no, because in a nutshell, blockchain is a very static in nature. So you can add data to it. The data will remain secure in a decentralized fashion. You cannot modify it, but that's pretty much it. I mean, when you think about complex use cases like NFTs, let's say, or ERC20 tokens, or entire crowdfunding, or flash loans in DeFi, for example, blockchain alone is not capable of doing all these things. So basically, what exactly helps it do it? So that's exactly where smart contracts come into play. At the heart of it lies smart contracts. So almost everything interesting that you see about Web3 right now, chances are it's built using the smart contracts. So yeah, let's start into a smart contract, what exactly it is, how it originated. And I don't think we can talk about smart contracts without talking about the person who actually invented it. So Nick Szabo, in 1994, he was the first one to propose smart contracts. Uh, Contrary to what most of us might believe, that smart contracts came after Bitcoin, it's not really true. It was way before Bitcoin. It just gained its popularity after Ethereum in 2015, because Ethereum was the first one to actually use smart contracts very effectively, right? All right, now let's understand smart contracts, and this is where all the fun begins. So an eagle-eye perspective of understanding smart contracts is comparing it to a vending machine, right? If you go on the internet now and you try understanding smart contracts, chances are you will find this example where many people just compare smart contract to a vending machine. But why do they do that? So let's forget about smart contracts for a second. Think about vending machine. What vending machines are, in a nutshell, they basically are automated shops, right? So there are products to be sold. There are customers who want to buy the products. You pay the money, but there is no shopkeeper who actually runs it. Everything that you do with a vending machine, it's predefined with a set of rules. For instance, if you need a Coke that costs $10, you pay $10 and then you get the Coke. You won't get it for $5. But this entire thing happens without the need for anyone to control or govern it, right? It happens automatically. It happens on a predefined set of rules, which basically means that valid inputs with the valid conditions give you the valid output. Smart contracts are very similar, right? It's a piece of code that executes without the need for any human to govern it. It is not just capable of documenting the laws, but also enforcing the laws. And I'll talk about this one again later when we learn more about smart contracts. But for now, let's imagine a smart contract that has a function, which is a withdraw function, let's say, right? So what that function allows you to do is it allows you to withdraw 100 tokens for every 7 days, right? So those are the conditions. You can only withdraw 100 tokens after every 7 days. Now, what are the valid inputs? So you come to that function, you click on it, but you pass 100 as the argument, which basically means that only when you are trying to withdraw 100 tokens, that contract will work. Only when you are withdrawing that 100 tokens in an interval of 7 days, that contract will work. So valid input is 100, let's say, and valid condition is after every week, right? The smart contract will only execute if both of these things are met. If you are passing 1,000 tokens, which you're not allowed to do, the smart contract knows that that's against the law. It will not allow you to withdraw any tokens, right? If you withdraw 100 tokens now, and then you come back again after 2 days instead of 7 days, according to the law of the smart contract, again, it won't work. It only works when valid inputs meet the valid conditions, which technically leads to the valid output, which is you can withdraw the 100 tokens, right? That's just the overview of how smart contracts can be compared to vending machine. But yeah, now let's move on. So in a nutshell, smart contracts are self-executing digital contracts. They execute only when a particular condition is met. They are immutable in nature, by the way. This is very important because you have to understand that the code that we write in smart contracts, they're not mutable. So if I write a code and I deploy it on a blockchain, even I cannot change it. And that's actually what lies at the core of Web3 is that even the person who writes a smart contract cannot change it because smart contract uses the inherent nature of blockchain, which is immutability, right? Uh, Smart contracts eliminates the need of middlemen. So like I mentioned, it is not only capable of documenting the laws, it's also capable of enforcing those laws on users, right? It wipes out any central authority control, which basically means that if there is no middleman, it does not need any human to govern and basically say that this is how it should work. It basically wipes out any central authority control. But that's all theory, right? That's not the fun part. The fun part begins when you actually start understanding how these are developed. And for that, I have made a small example through which you can understand this very better. Uh, so, okay, forget about everything. Just imagine this case. So there are two actors, Alice and Bob. They both want to do a trustless transaction. Trustless is important because they are from different corners of the world. They don't know each other. They don't want to know each other. They just want to do a transaction wherein Alice provides some service, let's say freelance service. Bob, in exchange for that service, will give some money, right? That's pretty much it. But how do they do it? So what exactly is the most effective way of for them to exchange these services in a trustless fashion so that they don't have to know each other, but still the works get done in an effective manner, right? So Alice and Bob both decides what to do. They think there are two options. They can either go to a traditional uh, escrow service or they can use a smart contract. Escrow, by the way, basically means that one central entity can hold your money or your product until the conditions are met, right? So that's what traditional escrow is, or they can use a smart contract. So they first look into the traditional escrow contract thing, right? What they find is there are quite a few cons when you think of using escrow contracts. First is you put a lot of trust in central authority, right? There is a third party, you don't know about it. You are keeping your money with it with no guarantee that they will not do anything malicious. Second is it's not really deterministic. Because there are humans involved in this process, there is a traditional escrow company which ensures that your transaction will happen very effectively, but there is no guarantee, it's not deterministic, right? What about the speed? So where any process that involves a lot of human, chances are it gets pretty lengthy. It involves a lot of paperwork, legal work. So the speed is pretty much low. What if Alice and Bob wants to do it in a weekend? Maybe the company is closed at that time, right? It's heavy on the wallet because it's a long procedure. It's going to cost a lot. Is it reusable? It's not reusable. So maybe Alice and Bob, they want to do this transaction once, but then they say, hey, I want to do it again. To do it again, they have to create a new contract again and start the process all over again, right? So these are all the cons that they find in traditional escrow contract. So they decide, hey, let's just go with the smart contract. Now, just think about it. They eliminated this entire middleman, this entire centralized authority with the smart contracts, and it's actually doable. But just imagine if you are the developer who is going to develop this smart contract, right? Your smart contract will basically store funds, will basically store rules on when to withdraw those funds, on who can withdraw those funds, and what if someone does anything bad. So your smart contract also needs to encode laws that not only rewards the good actor, but also punishes the bad actor. Now, all of this you have to code in a smart contract, which, by the way, will not be governed by any human. So there will be no human who will be looking at it, making decisions. It's all code. I want you to understand that this is really tricky to do because the code that you're going to write now for Alice and Bob, that will get deployed to blockchain. And once it gets deployed to blockchain, you can't change it. So it's really important to understand how you develop this smart contract. Now, because it's really a high intensity task and it requires a lot of brainstorming, you don't simply start with coding the smart contract, just like you start coding with any other language. First of all, it's important for you to define two things. First, defining the checkpoints. where exactly are the checkpoints? Where exactly do I need to enforce the laws for this transaction to happen properly? Second is designing the game theory, which basically means it should be a win-win for everyone. So where Alice or Bob both are in the transaction, any good actor should be rewarded, any bad actor should be penalized, right? All of these things you have to sort of document or brainstorm beforehand before you even start lighting a single piece of code, right? Now, when you think about it this way, you sit down with a piece of paper and you think what all could go wrong, right? So in our case, just in case you forgot, so the case was Alice wants to provide a service to Bob, let's say any service, any product. Bob, in exchange of the service, will give some money to Alice, right? And it needs to happen in a trustless fashion. Now, the things that can go wrong, and by the way, there are a lot of things that can go wrong. So you have to think about it a lot, but just to give an idea of how you can approach developing smart contracts. So the first one, what if Alice never initiates the transaction? What if Alice says that, hey, I am ready to give you the service, but she never does it? What if Bob never confirms the transaction? So Bob is an important player. For example, if I am Alice, I am going to give the transaction or give the service to Bob. Uh, and I only get the money when Bob confirms that, hey, I received the transaction. But what if Bob never confirms it? So what if he says, no, I didn't receive it? That means Bob is a bad actor. The smart contract should be able to penalize and punish Bob, right? Or what if the transaction never gets completed? What if both the parties are involved, but for some reason the transaction doesn't get completed? What happens then? Do the funds get logged in a smart contract, or what happens after that? These are the checkpoints. These are things that you have to think about before writing the smart contract, because that is what will define how you code that smart contract, right? All right. So now we know these are the checkpoints. So we go one step ahead and we say, okay, what can we do to minimize the amount of mess ups that can happen in this smart contract? So first rule that you define is for this service to begin, for this transaction to begin, Alice must lock X amount of tokens in the smart contract. Now, you all should understand that smart contracts are capable of storing money, tokens. So Alice must lock X amount of tokens in the smart contract, first of all, which basically ensures that Alice is a serious actor. She is not messing around. She is actually serious about giving her services to Bob, right? Which is why she's proving it by locking some amount of token in the smart contract, correct? By the way, this is just one set of procedure of how you can do it. There are multiple ways of how you can design this smart contract. Second rule is Bob must lock X plus Y amount of tokens in the smart contract. Why is Bob locking more than Alice in the smart contract? Because, like I mentioned, Bob is an important actor here. Unless Bob confirms that the transaction was done, it won't be valid. So Alice won't get a single penny unless Bob confirms that the transaction was done. So we need to have something set for Bob that makes him a good actor, makes him play a significant good actor throughout the transactions, that makes him stay very firm to what he promised, right? Now, if Bob locks more than Alice, then he is bound to be a good actor, because now if he doesn't be a good actor, the smart contract will lock his funds forever, right? Or give it to Alice. But eventually, Bob will end up losing more funds than Alice. So he is supposed to be a good actor. Right, so Alice locks X amount of tokens, Bob locks a bit more than Alice. Alice initiates the transaction of the asset or whatever service she promised. Both parties can withdraw the funds only after Bob confirms, and Bob should confirm because he has staked more tokens than Alice. By the way, if no transaction happens within a predefined amount of time, both parties can withdraw their funds, but with some deduction because they did not obey the entire transaction. All of these rules you have written down on a piece of paper, and these needs to be developed and coded in the smart contract. Once you do that, the smart contract should be able to govern and basically enforce all of these rules on its own, right? Now, reevaluating our checkpoints. So remember these checkpoints, right? What happens if Alice never initiates a transaction? Well, she loses her tokens because she has staked some tokens. She has proved that she's going to be a serious actor, but then she says, no, I'm not going to do it. If she says like that, she will eventually lose her tokens, right? What if Bob never confirms the transaction? So if Bob doesn't confirm the transaction, he loses even more token than Alice did, right? What if the transaction is never completed? If none of them fulfills it, they can withdraw their tokens, but with some penalty because they basically were bad actors because they didn't complete the transaction at all, right? This is how you approach about thinking of developing a smart contract. This is even before you write a single line of code, right? This is how you think about how to write smart contracts, because The moment you write smart contracts and deploy it, it will not be changed. You cannot be changing it. You cannot be changing any of the rules, right? So you have to be very sure of how you want to play this entire thing out. So now that you have the rules, now you have entire rules documented, the first step towards developing the smart contract is to convert this document into actual code. If you are developing a smart contract on Ethereum, chances are you will use Solidity for doing that. So now you write Solidity code in the basically develop the smart contract. Um, One thing to keep in mind here is to adhere to Solidity principles. The best development practices should be followed when you develop smart contracts. Anywhere that you see funds are involved, someone is depositing some funds or someone is capable of withdrawing some funds, you need to be very sure of how those functions are designed, because that is where the leak can happen, right? That is where a malicious actor can come in and take your funds away, right? So this is where the first step is to document the things that you want to do. Second is to convert the documentation into actual code. The third step basically is to test and audit the smart contract. Now, this is very, very important step because like I mentioned, smart contracts are immutable. So finding bugs in the smart contracts is really, really bad because it leads to two things. First, it's not like finding bugs in any JavaScript or web browser code, right? Because in any JavaScript code, you can always go and fix the bug. Doesn't matter if you've already deployed the site. But in smart contracts, you can't fix it once it's deployed. There are upgradable contracts. We can talk about it later. But even those have security issues, right? So the first reason for testing it thoroughly is the fact that you cannot change the code once you find issues if it's deployed already. The second issue is any bug in a smart contract does possess high chances of it leading to withdrawal of a lot of funds by some malicious actor. So whenever there's a bug in the smart contract, chances are your money will be gone because at all times your money is at stake when it's in the smart contract, right? So it's really important for you to test smart contracts right after you develop, or even better, parallelly run testing and developing both as you proceed the development, right? What is auditing? I'll come to that in a second. Then once you are sure that the smart contract is developed, it's tested properly, you deploy it on the blockchain, right? Deployment requires some sort of gas fees that is required for deployment. Once you deploy it, it gets distributed to all the parties of the blockchain, all the nodes, and that's when it becomes immutable. So now the escrow contract that we were trying to build, it was thought through, it was developed, it was tested, and it was deployed, right? Now, if you really look into it, a smart contract was not just able to define these laws that, hey, Alice should be a good actor or Bob should be a good actor. If Bob is a bad actor, let's punish him. A smart contract is not just able to define these laws, but also enforce it. Because once it's deployed on the blockchain, it doesn't really matter who runs it because it has wiped out the central authority control. It can now follow all these rules, penalize people or reward people on the basis of code. So the code is basically governing this entire transaction, right? If you compare it to the traditional way, it's far more fast. It's way faster. So now Alice and Bob can do this transaction whenever they want at their own speed. It's reliable, it's deterministic because like I said, if you can't change something after it's deployed, even if you wrote that thing, that basically means that you can't be a malicious actor and people can actually trust your code, right? It's cost effective because it has just reduced a long line of people and humans involved in the process. There is no paperwork that you have to do. It's deterministic and it basically eliminates any third party interference in the entire process. And this is why Alice and Bob chose the smart contract side. Now, you understand smart contracts, you understand how it works. You have seen a lot of its pros, advantages. But is it really all sunshine and rainbows? Are smart contracts the only solution to all the problems? The answer is no, because there are certain limitations of a smart contract that as a developer, you should understand. And even if you want to go into the Web3 world, you should understand that smart contracts are still at the very nascent stages and there are a lot of limitations, right? The very first one is security, and I'll talk about it in very extensive manner. Second one is immutability. So while it's a boon for us to have immutable code, the code that no one can change, as a software developer, I think we all understand that every code is supposed to have bugs, right? And we are supposed to fix it. But how do you fix a code that is immutable, that is already deployed on a blockchain? So that is, although immutability is one of the features of a smart contract, it's also sort of a limitation of a smart contract. To handle this, we now have upgradable smart contracts. So there is a way for you to change a smart contract code even when it's deployed, but that in itself is a very complicated process and also involves a lot of security threats. Third point is excessive dependency on the underlying blockchain. So uh, this limitation basically means that if you are writing smart contracts, let's say on Ethereum, and tomorrow Ethereum undergoes some major change in its architecture, chances are it might also affect your smart contract, right? Through no fault of your own, but because the underlying architecture and the underlying blockchain is going through some change, chances are smart contracts might get affected, uh, might even lead to some severe bug, right? Nascent stages. So solidity, the language that we use most often for writing smart contracts, is still at the very early stages. There are a lot of works that are being done, but if you look at the solidity documentation, you will find that almost every version of solidity had some sort of bug, right? Which might have affected a lot of smart contracts. Uh, and the last option, the last limitation is inability of smart contracts to interact with real world data. So it's sort of a trade-off, because when you think about it, smart contracts are very secure, they're decentralized, they are immutable, but at the cost of the fact that smart contracts cannot really interact with the real world data. So for that we have oracles, but still it's a limitation that you must be aware of. Now, because I've highlighted security, let's dive into security a bit, right? We really believed smart contracts are really smart unless the DAO hack that happened in 2016, and that really shook the Web3 world, because for the first time we understood how smart contracts can be hacked and what repercussions it will eventually lead to. So at that time, the DAO hack was it was a massive hack, right? It was due to a bug called reentrancy. We'll talk about it as well. 60 million Ether was stolen at that time. That was a lot of circulation of Ether at that time. Uh, the impact of this attack was so big that it ultimately led to a hard fork of Ethereum, which basically means Ethereum had to divide itself into Ethereum Classic and Ethereum blockchain, because there were people who were in favor of something while the other was not. So the DAO hack made us realize that smart contract hacks can lead to a disastrous outcome. And it's really important for us to not just write contracts, but also audit them, test them thoroughly, because any bug in smart contracts is not similar to bugs like in website or mobile apps, because those can be fixed, these cannot be. Uh, then comes the year 2020. This is the year where I decided to join smart contract security as well, and which is why I remember that it was one of the worst years for smart contracts, because almost every week there was a hack. There were a lot of different type of attack vectors that were introduced. We saw really cool hacks like flash loan attacks or price oracle manipulations, reentrancy bugs, and that's basically made us realize that even if smart contracts are solving a lot of problems, eventually if we are not able to control these hacks, and every hack, let's say, just wipes out millions of dollars, no one will come to Web3, because it's damn scary for someone to see that I put my money to something and then it just goes away, and no one is capable of doing anything, because the attacker or the hacker is also anonymous. So you can't really put him behind bars most of the time, right? So how do we solve it? I mean, it's a major issue. I mean, even if you're a smart contract developers, you have to be aware about security as well, right? So there are two possible solutions. First is following the best security practices. It is not as easy as it sounds, because this basically means that you have to be aware about every time something happens to Solidity, every time something changes in Solidity, so that your code is always up to the date, right? And second is smart contract security audits, right? That brings me to what audits really are. So although testing is all fine, we test the smart contracts. The developer writes test cases. We understand how a smart contract of a particular function is supposed to work, and we are also able to figure out, is it working in the way it is supposed to work or not. But audits basically involve a much thorough uh, review of the entire contract, mainly to find bugs that might lead to certain attacks that can wipe out funds, that can make someone else the owner of the contract, that can basically do anything that is not intended in the contract, right? So eventually there are 5 steps that I follow in my audit procedure, but smart contract audits usually have these 5 steps. So the first is to understand the code thoroughly, because this is also the fact that if someone else has written the code, it's always good to have a third set of eyes to look into it, and figure out if there is anything wrong. So if someone else have written a code, I'd have no idea what the code says, right? That's where documentation helps. So the first step towards smart contract auditing is you take the documentation from the developer. You are like, hey, I'm going to read the documentation, I'm going to understand your code, and then I'm going to check that what you want the code to do, is the code doing that thing or not, right? So you check the intended behavior of the code after you understand the code properly. So the first step is always documentation gathering, audit scope. You understand which contracts are supposed to be audited. You understand how those contracts are supposed to behave without looking into the code, but just talking to the developer, just talking to the, just looking at the documentation. Then you evaluate the test cases. So any code, any smart contract repository that has lower number of test cases, or that has test cases that are very poorly written, chances are it has a lot of bugs because that smart contract has not been tested thoroughly, right? So the second step that I follow is, after documentation understanding, I go to test cases. That also gives me an idea of how smart contracts are developed, right? How exactly they're supposed to behave. Then comes automated testing, which basically, in simple terms, it means, hey, computer, just tell me what's wrong with the smart contract. So there are a lot of tools right now that, for example, Slither, for example, Mythex. So these tools allow us to scan the entire code, tell us what is wrong with the smart contract. But most of the time, those are false positives because, like I said, solidity is still at the very early stages. There are a lot of things that automated testing tool cannot catch at the moment, which brings me to the fourth step, which is the manual code review. And this is the most important step. So manual code review basically means going through each line of code, trying to understand what can go wrong in any of this code, uh, trying to understand this contract, what other contracts do this contract interact with, and then understanding, is it leading to any attack vector, right? And then once you are done with this fourth step and you have identified a couple of issues in the contract, then it's time for you to document it very, very well. uh, I I wrote the word adequate documentation of reports because documentation is not just for the developer to see what's wrong with the code, but also for the community to see. So I mean, as you all might know, Web3 is a lot about community. So, but the fact that not everyone is technical, so everyone might not understand Solidity code. So they rely on auditors to provide a report that summarizes the security level of the contract. So it's important for you as auditor, if you become auditor, it's important for you to document the issues that you find in very plain English, in ways that is understandable to not just technical people, but also the non-technical people, because the community members are the one who are going to put their money in the smart contract, hopefully. But after reading your report, they should have an idea of whether they should put the money or not, right? So your report should be that clear. So this is how a smart contract audit works. So I just gave you an idea about how to develop smart contracts, how to audit smart contracts. And now it's time for me to move to the next slide.